is from machine learning algorithms to GenAI and LLMs. Master machine learning algorithms and generative AI and LLM with Python from scratch. Aman Agrawal, co-founder from machine learning algorithm, and these are some contents index. Overview, key features about authors: preparing a Python virtual environment for machine learning, creation of Python virtual environment, chapter first, machine learning algorithm, an overview, types of machine learning algorithms, and finally the machine learning techniques summary, chapter second, getting start with regression algorithms, linear regression, introduction, implementation of linear regression, advantage and disadvantage of linear regression, multi-regression, introduction, polynomial regression, introduction, implementation of polynomial regression, advantage and disadvantage, polynomial regression, rigid regression, introduction, implementation of rigid regression, advantage and disadvantage of rigid regression, lasso regression, introduction, implementation of lasso regression, advantage and disadvantage of lasso regression, elastic net regression, introduction, implementation of elastic net regression, advantage and disadvantage of elastic net regression. Second page, chapter third, linear classification algorithms, logistic regression, introduction, implementation of logistic regression, advantage and disadvantage of logistic regression, linear discriminant analysis, LDA, introduction, implementation of LDA, advantage and disadvantage of LDA, stochastic gradient descent classifier, introduction, implementation of SGD classification algorithms, advantage and disadvantage of SGD classification algorithms, summary, and chapter 4, performance evaluation methods, accuracy, precision, recall, FI score, confusion matrix, AUC and ROC, regression performance evaluation matrices, introduction, mean squared error, root mean squared error, mean absolute error, R squared, adjusted R squared, summary, naive bias, introduction, naive bias theorem, Gaussian native bias, multinomial naive bias, Bernoulli naive bias, advantage and disadvantage of naive bias algorithm, summary, support vector machines, introduction, the concept of decision boundary in SVM, implementation of SVM classification, SVM for regression, advantage and disadvantage of SVM, summary, decision tree and assemble method, introduction, decision trees, algorithms and assemble methods, the concept of assemble method and decision trees, chart ID3 SEEP 4.5, random forest, the concept of bagging in random forests, implementation of random forest, gradient boosting, the concept of boosting and gradient boosting, advantage and disadvantage of decision trees and enable methods, summary, boosting algorithms, getting started with ADA boost, the boosting process, weight updates, error minimization, implementation of ADA boost, XG boost, extreme gradient boosting, key enhancement in XG boost, implementation of XG boost, summary, clustering algorithm, k-means, implementation of k-means, advantage and disadvantage of k-means, AB scan, implementation of DB scan, DB scan, advantage and disadvantage of DB scan, algorithmic clustering, implementation of algorithmic clustering, bridge clustering, implementation of bridge clustering, advantage and disadvantage of bridge clustering, mean shift clustering, implementing of mean shift clustering, advantage and disadvantage of mean shift clustering, summary. Chapter 10, important data processing elements to train better models, getting started and handling missing values, handling outliers, feature selection, principal component analysis, feature scaling, hyperparameter tuning, SMOTE, a summary, neural network architecture for deep learning, introduction, computational structure of neural networks, how neural network work, getting started with perceptron, multi-layer perceptrons, convolutional neural networks, recurrent neural networks, long short-term memory networks, generative adversarial networks, transformer networks, exploring time series forecasting algorithms, introduction, getting started with ARIMA for time series forecasting, SARIMA for time series forecasting, summary, mastering GenAI and LLMs. So what are LLMs? Understanding the core concept of LLMs. Let's start with tokenization and embeddings, self-attention mechanism and multi-head attention, positional encoding, type of LLMs and their applications, auto-encoding models, auto-regressive models, sequence-to-sequence models, S2S, sec-to-sec models, multimodal models. Summary, Chapter 14, Understanding the Gens and Generative AI with a hands-on project, key components of GAN, noise vector, the generator network, the discriminator network, building a GAN model, combining generator and discriminator, training the GAN, analyzing the training process, summary, appendix, all parameters of commonly used machine learning algorithms, linear regression, polynomial regression, rigid regression, lasso regression, elastic net regression, logistic regression, linear discriminant analysis, stochastic gradient descent classifier, naive Bayes, support vector mechanics, machines, support vector machines, decision trees, random forecasts, random forests, gradient boosting, k-means, db scan, and convolutional neural networks, recurrent neural networks. Final words from the author. Here's the overview about the author. Preparing Python virtual environment for machine learning. Before getting started this book, it is highly recommended to set up a Python virtual environment for machine learning. Although you can use tools like Google Colab, which is completely ready to use for machine learning, still if you are aiming to learn machine learning, setting up Python virtual environment in something you should know. A Python virtual environment is self-contained workspace that allows you to isolate Python projects and their dependency from each other. It helps avoid conflicts between different project requirements and ensure that packages installed for one project do not interfere with others. This is particularly useful when working on multiple projects with different packages versions or when collaborating with others. In Python virtual environment for machine learning, you typically need to install the following essential libraries and packages: numpy for numerical computations and arrays, pandas for data manipulation and analysis, matplotlib, seaborn and plotly for data visualization, scikit-learn for machine learning algorithm and tools, TensorFlow or PyTorch for deep learning models. Creating a Python virtual environment. To set up the Python virtual environment, follow the steps mentioned below. Step first is open command prompt terminal in case of Mac. Step second, install virtual limp by running pip install virtualim environment, virtual environment, that means pipelining. Step 3, navigate to directory where you want to create a virtual environment using the cd command. And step 4, creating a virtual environment named environment env by running virtually env dot. Step 5, activate the virtual environment with the command dot such that dot slash environment slash script slash activate. If you are using Mac, when you have to install pip in your system, before following the above process, you can install the pip in your system by executing the command mentioned below, the curl https such that /bootstrap dot pypa.io /get pip py o get pip py. Once the virtual environment is activated, you can start installing the required libraries and packages using pip. Below are all the Python libraries you need to install in your virtual environment: pip install numpy, pip install pandas, pip install matplotlib, pip install cbar. Pip install plotly, pip install scikit-learn, pip install keras, pip install tensorflow. In case of Mac, pip install TensorFlow will not work. Below are the commands that will install TensorFlow in your macOS OS. Pip install TensorFlow macOS, pip install TensorFlow Metal, pip install TensorFlow datasets. Chapter 1, Machine Learning Algorithm and overview. Welcome to the exciting world of machine learning. If you are new to this field, you might be wondering what machine learning is and how it can be used to solve real world problems. Machine learning is a subset of artificial intelligence AI that focuses on development of algorithms and statistical models that enables computers to learn and improve their performance a specific task without being explicitly programmed in. It involves creating mathematical models that learn from and make predictions or decisions based on data patterns. The main goal of the machine learning is to allow computers to adapt and improve their performance over time by learning from new data. These enabling them to make accurate predictions, safely objects, and optimize decisions without human intervention. Machine learning algorithms are a set of rules and mathematical models that enables computer to learn patterns from data and make predictions and decisions based on that learning. These algorithms analyze data, identify patterns, and create mathematical representation that can be used to make predictions or solve specific problems. There are various types of machine learning algorithms, including supervising learning, learning from labeled data, supervised learning, learning from unlabeled data, and reinforcement learning, learning from feedback or rewards. Here are some examples of how machine learning algorithm can be used to solve business problems. Customer segmentation. Machine learning algorithms can be analyze customer data such as purchase history and demographic information to segment customers into distinct group based on their preferences and behaviors. This segmentation can help the businesses target specific customer segments with personalized marketing strategies and improve customer satisfactions. Credit risk assessment. Financial institution can use machine learning algorithm to analyze historical customer data and credit scores to assess the credit risk of loan applicants. This helps in making more accurate and data-driven decision on loan approvals and interest rates. Second, predictive maintenance. Machine learning algorithm can analyze sensor data from industrial equipment to predict potential equipment failure before they occur. This enables business to schedule maintenance proactivity, reducing downtime and minimizing operational costs. Demand forecasting. Retailer can use machine learning algorithm to analyze historical sales data and external factors like weather and holidays to predict future demand for products accurately. This helps in optimizing inventory levels and supply chain management. Neural language processing (NLP) machine learning algorithms can be used in NLP applications to analyze and understand human language. Business can be NLP to automate customer support through chatbots, sentiment analysis of customer feedback, and extracting valuable insights from unstructured and text data. Image and speech recognition machine learning algorithm can be employed in image and speech recognition system. Business can be use these systems for various purposes such as facial recognition for security applications, voice controlled virtual assistants, and automatic image tagging for originating large image databases. In short, machine learning means using data and algorithms to build intelligent systems that help in solving business problems. Types of machine learning algorithms. In the world of machine learning, there are three main types of algorithms: supervised learning, unsupervised learning, and reinforcement learning. Each of these type of algorithms has its own unique approach to learning from data and making predictions or decisions. Supervising learning. In supervising learning, the algorithm needs to learn from labeled data, which means the input data is already associated with known output values. The goal of algorithm is to learn mapping function from input to output that can be used to make predictions about new unseen data. Supervised learning algorithms can be used for tasks such as regression, classification, and prediction. Unsupervised learning. In unsupervised learning, the algorithm needs to learn from unlabeled data, which means the input data is not associated with any known output value. The purpose of the algorithm is to identify patterns and relationship in data without any prior knowledge of what data represents. Unsupervised learning algorithms can be used for tasks such as clustering, anomaly detection, and dimensionality reduction. Reinforcement learning. In reinforcement learning, the algorithm learns to make decisions by interacting with an environment and receiving feedback in the form of rewards or punishments. The goal of algorithm is to learn a policy that maximize and cumulative reward over time. Reinforcement learning algorithm can be used for tasks such as gaming, robotics, and autonomous vehicles. So labeled data is the data that has been manually annotated and labeled with unknown output values or target variables. In other words, labeled data is data that has been assigned a specific category or classification by human experts. This means that the input data is already associated with known output values of target variables, making it deal for use in supervising learning algorithms. On the other hand, the unlabeled data is the data that has no known output values or target variables. In other words, the input data has not been manually annotated or categorized, and or algorithm must identify patterns and relationship in data without any prior knowledge of what the data presents. This makes unlabeled data deal for use in unsupervised learning algorithms. And finally, the machine learning techniques. Machine learning is a large, complex and field with many techniques and algorithms designed to solve a wide range of problems. Here are some most common techniques used in machine learning. First one is regression. Regression is a technique used to predict a continuous output variable based on one or more input variables. Linear regression is one of the most commonly used type of regression in machine learning, where the output variable is predicted using linear function of input variable. Classification is a technique used to predict a discrete output variable based on one or more input variables. This technique is commonly used in tasks such as image classification or spam filtering. Common classification algorithm including logistic regression, decision trees, and support vector machines. Clustering is a technique used to group similar data points based on their characteristics. The technique is commonly used in tasks such as customer segmentation and image segmentation. Common clustering algorithms include k-means clustering and hierarchical clustering and density based clustering. Dimensionality reduction. Dimensionality reduction is the technique used to reduce the number of features and variables in a data set without losing important information. This technique is commonly used in tasks such as data visualization and feature selection. Common dimensionality reduction algorithms including principal component analysis, TSNE, and autoencoders. Assemble methods enables. Methods are techniques that combine multiple machine learning models to improve their accuracy and robustness. This technique is commonly used in tasks such as predicting stock prices, detecting fraudulent transactions. Common enable methods including bagging, boosting, and random forests. Deep learning is a subset of machine learning that uses artificial neural networks to learn complex patterns and relationship in data. This technique is commonly used in tasks such as speech recognition, image classification, and neural language processing. Common deep learning architecture including convolution neural networks, recurrent neural networks, and transformers. These are just a few of many techniques used in machine learning. Each technique has its own strengths and weaknesses, and choosing the right technique for particular task requiring careful consideration of data and the problem at hand. As machine learning continues to evolve, new techniques and algorithms will continue to develop, making it an exciting and dynamic field. Summary. These are the summary of the first chapter in this book, and so let's begin. Chapter 2, getting started with regression algorithms. Regression is a statistical technique used to estimate the relationship between one or more independent variables and dependent variables. It is supervised learning techniques commonly used in machine learning to predict continuous outcomes. Regression analysis allows us to model the relationship between the independent variable and the dependent variable and use this model to make predictions make new data about new data. Regression algorithm are machine learning algorithm that uses regression analysis to predict continuous outcomes. It is in this chapter we'll explore the most common regression algorithms used in machine learning, including linear regression. Linear regression is the simplest type of regression algorithm used in machine learning. It models the relationship between the independent variables and the dependent variables using the linear function. Logistic regression. Logistic regression is a type of regression algorithm used for classification problems. It models the probability of the binary outcome based on independent variables. Multiple regression is the extension of linear regression that allows us to model a relationship between multiple independent variables and single dependent variables. Polynomial regression is a type of regression algorithm that models the relationship between the independent variables and dependent variable using polynomial functions. Rigid regression is a type of regression algorithm used to solve the problem autocollinearity in multiple regression. It adds the regularization term to cost function to avoid overfitting. Lasso regression is another type of regression algorithm used to solve the problem of multicollinearity and multiple regression. It uses different type of regularization term that rigid regression. Elastic net regression is a culmination of rigid regression and lasso regression. It uses the both type of regulations term to solve the problem of multicollinearity. Linear regression introduction. Linear regression algorithm is used to analyze the relationship between the two variables, namely independent variables x and the dependent variable y. It helps us to understand how changes in the independent variable affect the dependent variable. By fitting the line of data, the algorithm allows us to make predictions or draw a conclusion based on this relationship. It works by defining the best fitting line that minimize the differences between observed data point and predict values on the line. It achieves this through the process called ordinary least squares, OLS, ordinary least squares. The algorithm calculates the optimal values for the intercept beta naught and slope beta 1 of the line that minimize the sum of squared error between the predicted value and the actual data points. The mathematical formula for simple linear regression is y equal to beta naught plus beta 1 x, where here y represent the dependent variable and x represent the independent variable. Beta naught represent the y intercept and value of y when x is 0. Beta 1 represent the slope of regression, a line that change y for 1 unit change in x. So linear regression can be used in variety of real world business problems such as prediction sales based on advertising spend, prediction a price of house based on its feature, predicting the number of customer service calls depending on the time of day. How to identify in your problem can be solved using linear regression algorithm. To determine if the problem can be solved using linear progression, we need to determine if there is a linear relationship between the independent variables and the dependent variables. This can be done by plotting the data and looking for linear pattern. We can also use the correlation analysis of to measure the strength of the relationship between variables. If the relationship is linear regression may be good candidate algorithm to use. Implementation of the linear regression. In this section we will explore the implementation of the linear regression algorithm using Python. Implementing linear regression and all other machine learning algorithm covered in this book. We will use the scikit-learn library. Scikit-learn is a popular machine learning library or Python that provides a range of tools for data mining and data analysis. This is built on top of NumPy, SciPy, and Matplotlib, which are other popular Python libraries in scientific computing data visualization. NumPy, Number Python, Scientific Python, MATLAB Python. I think MATLAB plotting something. In install scikit-learn, you can use pip pipelining process or package installer for Python. Open the terminal or command prompt and type the following command: pip install -u scikit-learn. This will be download and install the latest version of scikit-learn. In addition to scikit-learn, we will also need to install other libraries needed for the implementation, including NumPy, Pandas, and Plotly. You can also install these libraries using pip install NumPy, Pandas, Plotly. Now that we have necessary libraries installed, let's implement linear regression using scikit-learn. We'll be start by importing the necessary libraries. Import NumPy as np, import plotly.express as px, import plotly.graph-objects as go. From sklearn.model-selection import train-test-split. from sklearn dot linear dash model first import linear regression. Let's create a complex data set with the quadratic relationship between independent variable x and the dependent variable y. Hashtags step first, such that creating a complex data set np dot random dot seed of theta x is equal to np dot line space of theta 10 and 100. Hashtag independent variables y is equal to 3 multiplied by x double star 2 plus 2 star x plus np dot random dot normal of parenthesis 0 10 and 100. Now let's divide the data into training the test set. Hashtag step second, such that splitting the data into training and testing sets s dash train comma x dash test comma y dash train comma y dash test is equal to train dash test dash split of parenthesis x y x comma y test slash dash size is equal to 0.2 comma random dash state is equal to 42. Now let's create an instance and linear regression class and fit it to training data. Hashtag step 3, implementing linear regression. Model is equal to linear regression and this parenthesis x dash train is equal to x dash train dot reshape minus 1 to 1. Hashtag reshaping x dash train to 2D array, two-dimensional array model dot fit of parenthesis x dash train comma y dash train and hashtag training the model. We have fitted the model to training data, and now we can use it to make predictions on the test data. X dash test is equal to x dash test dot reshape of parenthesis minus 1 to 1. Y dash predicting is equal to model dot predict of x dash test. Finally, we visualize the result using the plotty library. Hashtag step 5, such that visualizing the result using plotty figure is equal to go dot figure parenthesis figure dot address add dot dash trace of parenthesis go dot scatter of parenthesis x is equal to 1 dash test dot flatten parenthesis dot y is equal to 1 dash test common mode is equal to the inverted markers name is equal to inverted actual parenthesis of figure point add dash trace of parenthesis go dot scatter of parenthesis x is equal to 1 dash test dot flattening and this parenthesis comma y is equal to y dash prediction pred comma mode is equal to it is inverted lines comma name and linear progression inverted regression linear regression figure point updated dash layout of this parenthesis title is equal to the inverted linear regression x axis dash title is equal to inverted independent variable of parenthesis x and y-axis dash title is equal to inverted dependent of parenthesis y. Figure point show parenthesis. Here's the response for that. Dependent variable y, this is minus 50 50 50 100 50 50 slots, and 0 2 are the independent variables in axis 0 2 4 6 8. So this is the response. The slope of the line represents the relationship between two variables, and as you see the slopes is positive, which means that as independent variable increases, the dependent variable also increases. This increases, this both these increases. Advantage and disadvantage of linear regression. Linear regression has several advantages that make it widely used algorithm. First, it is simply and easy to understand algorithm that is well suited for beginners in machine learning. Second, it is parametric algorithm, which means it can be easily interpreted and explained. Third, it is highly scalable and can handle large data sets. However, this use of linear regression regression also has some disadvantage. For example, it assumes a linear relationship between independent and dependent variables, which is not always the case in real world scenarios. Moreover, it is sensitive to outliers, which means that the presence of even and few extreme values can have significant impact on the results. Finally, it may not work well when there are non-linear relationship between variables. Multiple regression. Introduction. Multiple regression is a type of linear regression that allows more than one independent variable to be included in the model. The algorithm works by finding the linear or plane of the best fit that minimizing the sum of squared error between the predicted value and the actual values. Multiple regression can be used in a variety of real world businesses problems, such as predicting the price of house based on location, size, and the other characteristics, or estimating a company's revenue based on advertising spend, number of employees, and other factors. It can also be used to identify the most significant factors contributing to dependent variable and to quantify the strength and direction of their relationship. How to identify if your problem can be solved using multiple regression. So determine whether a problem can be solved using multiple regression being by the looking at the relationship between the dependent variable and the each independent variable. If there is a linear relationship between the dependent variable and two or more independent variables, multi regression may be an appropriate approach. Additionally, it should be determined whether any confounding variables may affect the relationship between the independent and dependent variables. If so, these variables may need to be included the model and controlled for it in analysis. To implement the multiple regression model, you can implement the same step and data set with multiple independent variables that you use to implement a simple regression model. If your data has multiple independent variables, the resulting model will be multiple regression model rather than simple regression model. Polynomial regression. Introduction. Polynomial regression is a statistical algorithm used to model the relationship between dependent variables and one variable and one or more independent variables. It is a type of regression analysis where the relationship between the variables is modeled as an nth degree polynomial. And the polynomial regression algorithm works by fitting a polynomial equation to the data points, aiming to find the best fitting curve and presents the relationship between the variables. It extends the linear regression model by introducing higher degree polynomial terms, allowing for more flexible and curved relationship to be captured. The mathematical formula for polynomial regression is y is equal to beta naught plus beta 1 x plus beta 2 x square plus beta 3 x cube plus and so on beta n x raised to n plus epsilon is the error. Here y represent the dependent variable, x represent the independent variable, epsilon is the error term, and coefficient beta naught, beta 1 up to and so on are the parameters that need to be estimated to determine the best fitting polynomial curve. How to identify if your problem can solve using polynomial regression. To determine if the problem can be solved using polynomial regression, one must first examine the relationship between the independent and dependent variables. If there is a non-linear relationship such as quadratic or cubic relationship, polynomial regression may be appropriate approach. The example of quadratic and cubic relationship: here's some hyperbolic function is a parabolic function, and quadratic 0 minus 5 0 5 10 x and y axis 0 20 40 60 80 is quadratic relationship. And a cubic relationship minus 10 minus 5 0 5 10 and minus 1000 minus 500 0 500 and 1000. So this is the response. Implementation of polynomial regression. Now let's see how implement the polynomial regression algorithm using Python. I'll be start by the importing the necessary Python linearity and creating the independent variable x and the dependent variable y. Import numpy as np. Import the matplotlib dot pilot as plt from skylearn dot pre-processing import polynomial features from sklearn dot linear dash model. First import linear regression np dot random dot c dot theta x is equal to np dot landscape space of parenthesis 0 theta 0 10 100 and hash tag independent variables. Y is equal to 3 star x double star 2 plus 2 star x plus np dot random dot normal of parenthesis 0 10 100 hashtag dependent variables with noise. Reshape the x and y array to column vectors. X is equal to y x dot reshape of -1 to 1 and y is equal to y dot reshape parenthesis -1 to 1. Split the data into training the testing sets. X dash train comma x dash test comma y dash train and y dash test is equal to train dash test dash split of parenthesis x y and text dash size is equal to 0.2 comma random this dash state is equal to 42 and transform the independent variable x with polynomial features. Poly dash features is equal to polynomial features of parenthesis degree is equal to 2 x dash train dash poly is equal to poly dash features dot fit dash transform of parenthesis x dash train and x dash test dash poly is equal to poly dash features dot transform of x dash test. In the code above we have created the polynomial feature object with degree of 2. This will generate second degree polynomial features. Next we need to create as instance of linear regression class and fit the polynomial characteristics to the model. Model is equal to model is equal to the linear regression of parenthesis model dot fit of parenthesis x dash train dash poly comma y dash train and generate predictions on training and test sets. Y dash train dash predict pred is equal to model dot predict of parenthesis x dash train dash poly and y dash test dash pred is equal to model first dot predict of parenthesis x dash test dash poly. Visualize the original data and the polynomial regression curve. Import plotly dot graph dash objects as go hashtag scatter plot for training data trace dash train is equal to go dot scatter of parenthesis s is equal to x is equal to x dash train dot flatten of parenthesis dot y is equal to y dash train dot flatten of parenthesis comma mode is equal to the inverted markers comma name is equal to inverted training data comma marker is equal to predict of color is equal to inverted blue and the hashtag scatter plot for testing data trace dash test is equal to go dot scatter of parenthesis x is equal to x dash text dot flatten of this parenthesis comma y is equal to y dash test dot flatten parenthesis comma mode is equal to markers inverted comma name is equal to testing inverted data marker is equal to dict of color is equal to inverted green and has a line plot for polynomial regression trace dash regression is equal to go dot scatter parenthesis is equal to x dash train the flattening parenthesis dot y is equal to y dash train dash spread dot flatten parenthesis dot mode is equal to the inverted lines comma name is equal to inverted polynomial regression comma line is equal to dict color is equal to red inverted bit is equal to 2 parenthesis of hashtag create the layout for plot layout is equal to go dot layout of parenthesis title is equal to inverted polynomial regression comma x axis is equal to dect of parenthesis title is equal to inverted x and comma x is equal to dect parenthesis title is equal to inverted y parenthesis of and hashtag combine the trace and the layout and create the figure is equal to go dot figure of parenthesis data is equal to the bracket trace dash train comma trace dash test comma test dash regression comma layout is equal to layout parenthesis of and hashtag show the plot figure dot show a parenthesis polynomial regression the x-axis y-axis 0 2 4 6 8 and 10 and 0 50 100 150 1 slots that's training data that's testing data is polynomial regression. It's representation of this coding. Well, advantage and disadvantage of polynomial regression. The advantage of polynomial regression are that it can model non-linear relationship between dependent and independent variables and can provide a better fit for data than linear regression. However, the drawback are that it can be prone to overfit if the degree of polynomial is too high, and it can be computationally expensive for large data sets for high degree polynomials. Rigid regression introduction. Rigid regression is a statistical algorithm used in machine learning to handle the problem of multicollinearity, which occurs when predictor variables are highly correlated. It is extension of the ordinary least square regression method. Least square regression method is specifically designed to address the issue of overfitting in models with many variables. Multicollinearity refers to situations where predictor variables are highly correlated with each other. It can cause issues in traditional linear regression, such as unstable and unreliable coefficient estimation. However, the rigid regression helps mitigate these problems by reducing the impact of multicollinearity. Mathematical formula for regression rigged rigged ridge ridged regression is beta is equal to the parenthesis of x this vector t x plus lambda I of this vector notation dash 1 x raised to vector ty notation, where beta is the vector of coefficient, x is a matrix of dependent variables, y is a vector of values of dependent variables, lambda is the penalty parameter, and I is identity matrix. Ridge regression works by introducing the penalty term controlled by regularization parameter lambda, and to ordinary test squares equation. The penalty term restricts the magnitude of coefficient estimates, thereby reducing their sensitivity to small changes in input data. By adding the penalty ridge regression shrinks the coefficient towards 0, but they do not become exactly 0. This allows the algorithm to handle multicollinearity and provide more stable and reliable predictions. How to identify if your problem can be solved using ridge regression? To determine if the problem can be solved using ridge regression, one must first determine if the independent variables are strongly correlated. This can be done by calculating the correlation matrix between independent variables. If there is a strong correlation between the variables, ridge regression may be appropriate algorithms. Additionally, the traditional regression model are overfitting or model coefficients are large, ridge regression can be used to improve model accuracy. Implementation of ridge regression. Now let's see how implement the ridge regression algorithm using Python. We'll start by importing the necessary Python libraries and data set. Import pandas as PD from sklearn.datasets. Import load dash data diabetes data is equal to load dash diabetes parenthesis x is equal to pd dot data frame of parenthesis data dot data comma columns is equal to data data dot feature dash names y is equal to pd data frame parenthesis data dot target comma columns is equal to the bracket of inverted comma target parenthesis of. Next we need to split the data into training and test sets from sklearn.model dash selection import train by dash test dash split x dash train comma x dash test comma y dash train comma y dash test is equal to train dash test dash split of parenthesis x comma y comma test dash size is equal to 0.2 comma random dash state is equal to 0. Next we need to create an instance of ridge class and fit the model to train data from sklearn.linear dash model import ridge regressor is equal to ridge of alpha is equal to 1.0 regressor dot fit of parenthesis x dash train comma y dash train. In the code above we have created an instance of rigid class with an alpha value of 1.0. This alpha value represents the penalty parameter which determines the strength of the penalty term in the regression equation. We can now make prediction on test data. Y dash pred is equal to regressor dot pred of x dash test. And to visualize the result we can use the plotty library to create a scatter plot of actual and predicted values. Import plotty dot graph dash objects as go figure is equal to go dot figure of parenthesis figure dot add dash trace of parenthesis go scatter of parenthesis x is equal to y dash test of bracket inverted comma target comma y is equal to y dash grid dot flattening of parenthesis dot mode is equal to inverted markers parenthesis figure point fig point add dash trace of parenthesis go dot scatter of parenthesis is equal to the bracket 0 to 350 dash y is equal to the bracket of 0 to 350 a mode is equal comma mode is equal to inverted lines parenthesis of figure dot upgrade dash layout and the title is equal to actual versus predicted inverted and comma x-axis dash title is equal to the inverted actual comma y-axis dash title is equal to inverted predicted parenthesis of figure point so parenthesis actual versus prediction. So it will give the output run like predicted and the actual, and this is the result. Here's the trace 0 and trace 1. So these are trace zeros dot dot and this trace 1. Advantage and disadvantage of rigged regression. The main advantage of the rigged regression is that it can handle highly correlated independent variables, avoiding overfitting and though to provide the better fit to data than traditional linear regression. It does this by adding penalty term to the regression equation which limits the magnitude of coefficients and help prevent the model from adjusting for noise in the data. The main disadvantage and ridged regression is that it can be difficult to determine the optimal value of the penalty parameter, and this value can be vary depending on the data set being analyzed. Also, ridged regression assumes that the independent variables are normally distributed, linearly related, and dependent variable, which may not be true in all cases. Lasso regression introduction. Lasso regression is type of regression algorithm used for feature selection regulation. It is similar to rigid regression, but it adds L1 penalty term to regression equation, resulting in a sparse model where some of the coefficient are set to 0. The mathematical formula for lasso regression is beta is equal to average minimum of parenthesis of summation of parenthesis yi minus beta naught minus summation j is equal to 1 to pxi comma jbj vector or raised to 2 square plus lambda summation of slash bj modulus of where the beta is vector of coefficient, beta naught is intercept term, xij is the value of jth independent variable for ith observation, yi is the value of the dependent variable for the ith observation, lambda is the parameter of penalty, and p is the number of independent variables. In lasso regression, the goal is to minimize the sum of squared residuals, just like ordinary linear regression. However, lasso introduced the additional term called L1 penalty or absolute value of coefficients. The L1 penalty encourages the coefficient or of less important features to become exactly 0, effectively forming the automatic feature selection. This characteristics test lasso regression apart from ridged regression, where the coefficient are only shrunk toward 0 but not exactly 0. To achieve this, lasso regression adjusts the coefficient during the model fitting process. As the penalty term increases, some coefficients are driven to 0, effectively excluding the corresponding features from the model. The amount of the shrinkage and feature selection in lasso regression is controlled by parameter called lambda or alpha. A higher value of lambda result in more aggressive coefficient shrinking and greater number of coefficient becoming 0. Lasso regression is commonly used in real business problems where there are many independent variables but only a few of them are important in predicting the dependent variable. This can happen in area of finance and market where the many factors can affect results, but only a few are truly significant. How to identify if your problem can be solved using lasso regression? To determine if the problem can be solved using lasso regression, one must first determine if there are many independent variables. Second, but only a few are actual important in predicting the development dependent variable. This can be done by performing an exploratory analysis of the data, examining the correlation matrix, scattered plots between the independent and dependent variables. If there are only few significant correlation, lasso regression may be appropriate algorithm to use. Additionally, if feature selection is required, lasso regression can be used to identify the independent variables that are most important in predicting the dependent variable. For implementation of lasso regression, now let's see the implementation of lasso regression. Using Python, we'll start by importing necessary Python library and datasets. So from sklearn.dataset import load dash diabets. From sklearn.linear-model first import lasso. From sklearn.model selection import train test split import pandas as pd. Data is equal to load diabetes parenthesis x is equal to pd dot data frame parenthesis data dot data common columns is equal to data dot feature dash names, and y is equal to pd dot data frame data dot target columns, and is equal to the bracket inverted target. Next we need to split the data into training the test set. X dash train, y dash train, comma y dash train, comma y dash test is equal to train dash test dash split of y comma x comma y test dash size is equal to 0.2 comma random dash state is equal to 0. Next we need to create the instance of lasso class and fit the model to train data. Regressor is equal to lasso of parenthesis alpha is equal to 1.0 and if the code above we have created the instance of the lasso class with an alpha value 1 of this alpha value represent the penalty parameter which determines the strength of penalty from in the regression equation. We can now make prediction on test data. Y dash spread is equal to regressor dot predict of the parenthesis x dash test. To visualize the result we can use the plotty library to create a scatter plot of actual predicted values. Import plotty.graph dash objects og as go figure is equal to go dot figure parenthesis figure dot address dash trace of parenthesis go dot scatter of parenthesis is equal to y dash test of the bracket target inverted comma y is equal to y dash spread dot flattening parenthesis comma mode is equal to the inverted markers and parenthesis of figure fig point add dash address trace a parenthesis go dot scatter of parenthesis x is equal to here the bracket 0 350 and comma y is equal to 0 350 dot mode is equal to line inverted and figure dot update dash layout of parenthesis little is equal to actual versus predicted comma axis dash little is equal to actual inverted comma and comma y-axis dash data is equal to inverted predicted parenthesis of figure point show a parenthesis actual and predicted and this is predicted, this is actual response and this is same as trace 0 trace 1. So this is the output and these are the codes. Thank you.